After decades of hard work, Webb started its work on July 2022. NASA released 5 images that were captured by Webb. The images were captured in IR spectrum of electromagnetic waves. Observations showed that our universe is expanding. This expansion of universe caused the light emitted by a distant galaxy get stretched from shorter visible spectrum to longer IR spectrum. This is why Webb uses IR instruments. These images shows lots of galaxies, stars and nebulae. These images were explained in this video. James Webb Space Telescope captured images of Jupiter during the commissioning process. This includes images of Jupiter and its moon including Europa and also several asteroids. This was shot by Webb's near-infrared camera. This image shows various bands of Jupiter. You can see a circular portion on the right of the planet. This is called Great Red Spot. According to NASA, this is a storm on Jupiter which is big enough to swallow the Earth. This spot appears white because it was captured on infrared spectrum and was processed. On the left of the planet, you can see a moon of the Jupiter called Europa. This moon is said to have ocean below its crust. Its shadow can be seen clearly on left of the red spot. Webb also easily captured the Jupiter rings. During commissioning, Webb also located and tracked an asteroid called 6481 Tenzing. It is located in the asteroid belt between Mars and Jupiter. Now let's see about the images captured by Webb. This is the image of Southern Ring Planetary Nebula catalogued as NGC 3132. It is also known as 8 Burst Nebula and is a planetary nebula in Vela constellation. It is approximately 2500 light-years away from the Earth. The dimmer star at the center has been sending out rings of gas and dust for thousands of years in all directions. Webb has revealed for the first time that the star is covered with dust. This image will allow astronomers to find why gas and dust is being expelled by a dying star. Midcam instrument image of the same nebula shows that the two stars are locked in a tight orbit, whereas the image from near-infrared camera shows like a single star. The brighter star is in early stage of evolution and will get ejected in future. As the SPAC continues to orbit one another, they actually stir the gases and dust, causing asymmetrical patterns. The fainter star is losing its mass. The gas and dust is mass continuously ejected from the star. Closer dust are emitted recently while the farther are emitted earlier. Lights emitted by the star passes through the gases and dust like a sunlight passing through a cloud. In thousands of years, these layers of gases and dust will dissipate into its surrounding space. The next image reveals the details of the Stephan's Quintet located in Pegasus constellation. Stephan's Quintet is a group of 5 galaxies. This is the largest image to date with 150 million pixels and constructed from almost 1000 images. The galaxies in this quintet are NGC 7320, NGC 7319, NGC 7318A and B, and NGC 7317. NGC 7320 is about 40 million light-years from the Earth, while the rest of the galaxies are about 290 million light-years away. Studying Stephan's Quintet helps us to understand the process of fundamental to all galaxies. The topmost galaxy NGC 7319 has an active galactic nucleus. It is a supermassive black hole that emits bright jets and winds and shapes the galaxies. In the closest galaxy NGC 7320, Webb captures the individual star and its brightest core. This image also shows some of the distant galaxies. Carina Nebula, catalogued as NGC 3372, also called as Great Carina Nebula in our own Milky Way galaxy. This is approximately 7600 light-years away from Earth. It was captured by near-infrared camera and mid-infrared instrument. It is a stellar nebula, which means the place of star birth. This image looks like a mountain on full moonlight with glittering stars. This is actually an image of a star-forming area of Carina Nebula. The mountain-like shape is called cosmic cliff, which is the nearby young star-forming region. Because of the Webb's IR sensitivity, it reveals emerging stellar nurseries and individual stars that are completely hidden in visible light pictures. The pointed peak is almost 7 light-years high. The ultraviolet radiation from new star erodes the nebula wall slowly. The stream-like mass that appears to rise from the cosmic cliff is a hot ionized gas and hot dust streaming away from nebula due to continuous radiation. As the bright ionized edge moves into nebula, it is slowly pushed into gas and dust. If the rim encounters an unstable material, the increase in pressure will cause the material to collapse and trigger the formation of new stars. WASP-96b is a gas-giant exoplanet with almost half the mass of Jupiter. This is the confirmed exoplanet in a Milky Way which is 1150 light-years away. It just orbits its star every 3.4 Earth days. This is the spectrograph image of the planet by near-infrared imager and slitless spectrograph. This image reveals the distinct signature of water, haze and clouds. It also reveals the presence of specific gas molecules based on the tiny decrease in color of light. On June 21, near-infrared imager and slitless spectrograph measured light from a star called WASP for 6.4 hours. The result light curve shows the dimming of the starlight during the transit of the planet. This transmission spectrum reveals the brightness change of the wavelength ranging from 0.6 to 2.8 microns. The light curve confirms the property of the planet that already recorded. The transmission spectrum reveals the presence of water, haze, clouds that were not found in previous observations. This is the most detailed near-infrared spectrum of an exoplanet atmosphere covering a wide range of wavelengths including visible red light. This observation made scientists happy that Webb has the power to characterize the atmosphere of exoplanets. This deep field image just covers the size of a small sand grain in the sky. A deep field image is the one that peers into the blackness of the space into the visible stars to capture distant dimmer stars. It will be taken with a very long exposure time. Because of the long exposure time, it allows the light even from faint objects to get captured. SMACS 0723 is a cluster of galaxies about 4.6 billion light-years away from Earth. It was taken by near-infrared camera with total exposure time of 12.5 hours. It was also imaged by mid-infrared instrument. It has huge number of galaxies. The combined mass of the galaxy cluster acts like gravitational lens. The gravitational field of galaxy cluster can bend the light rays from more distant galaxies. This effect is same as looking through a giant magnifying glass. This was confirmed by NIRIS's wide field slitless spectroscopy. Light from these galaxy clusters took over billions of years to reach us. That is, we are looking back in time. The light from these galaxies was stretched from visible to IR wavelength due to expansion of universe. These IR waves were absorbed by Webb. On visualizing mirror image of the same cluster, blue galaxies contain stars with little dust. Red objects are covered with thick layers of dust. Green galaxies are polluted with hydrocarbon and other chemical compounds. The first set of images makes scientists more curious to get unknown things out. These images provide proof that Webb is a powerful tool to look back in time. Finally, subscribe to our channel for more science related videos. Thank you. Have a happy day.